Hello, welcome for today's lesson. We are going to look at the landscaping the crust, and we'll be able to look at the faulting. When you look at the earth crust is built up of different layers, as we had looked upon in the previous lesson. And mark you, the oldest rock is the deepest one that is found beneath the other one. And the youngest one is always found above the other one. Therefore, these rocks, as they have been subjected in the process of sedimentation and also the other process of erosion, we look out that it is the top layer of the earth crust that is the one that is worn out. And in the process of it being worn out by erosion and weathering, this brings out a new figure of the earth crust, and that is what we call the landscaping. And therefore, under this, we shall also be able to look at the faulting as one of the landscaping agents in the process of bringing up new landforms on earth crust. Then, what is faulting? Faulting is the fracturing of the crustal rocks. Is the fracturing of the crustal rocks. As a result of the tectonic forces. As a result of the tectonic forces. And that is what it means, faulting. And therefore, when we look at faulting as a fracturing, the other word of fracturing is also splitting. That is a better now understanding. When the earth fractures, it has splitted. And this one is done as a result of the crustal rocks being subjected to a certain force that we had covered already, is known as the tectonic force. And there are three causes of faulting. One of the cause I will outline here is the tectonic. We have tectonic force. And then we also have another force that is called compression force. Compressional force. And then the third force that may also be responsible is the faulting force, tensional force, yes. We have the tensional force. These are the three forces which are responsible for the causes of faulting. And faulting produces what we call faults. Faults are the fractures which have been found on earth's surface or within the crustal rocks, especially when you subject them to these three forces. We'll also be able to move and look at the types of faults. Faults can be categorized into various category according to how they are formed. One we will have is the normal fault. We have what we call the normal fault. And then two, we have reverse fault. And then 3, we have transcurrent fault, transcurrent fault. And then we also have others which are also known as thrust fault. We have thrust fault, and anticlinal fault. Therefore, we can have these categories of faults, and then we'll be able to find the way out. How are the normal fault forms or formed, and how are the reverse fault formed? We'll also be able to look at the transcurrent fault, the thrust fault, and anticlinal fault. Let's look at how the normal fault and the reverse fault are formed. Normal faults are formed roughly vertical when the crustal rocks are subjected to equal a normal fault, therefore producing what we call a compressional fault. And then they will result into the formation of the normal fault, and that will work on the crustal layers of the crusts, producing a feature that look like this. A feature that will be produced will look like this in the resultant part. because of the tectonic forces, it is making this one to have, and therefore the feature that will be formed, the resultant feature will look like this, and then produce some down throw and up throw. Therefore, when we have an up throw and a down throw, it will result into the formation of this normal fault that is having the equal magnitude. That is having the equal magnitude when you look at it very careful, because the magnitude of the forces have equally the same action, and therefore resulting into this resulting to the formation of this feature. And when you look at it, it has got two faces, where the plane that is going to be distorted is what we call the fault plane. This is a distorted plane. We refer to it as a fault plane. In some cases of the inclination, and the angle between the fault and the vertical plane is called the head. This angle or this face, we refer to it as the head, written as this way, while the displacement that is produced in the down throw on the horizontal displacement is called the heave. This on the down throw is what we call the heave. This angle or this part, the plane that is distorted, we call it the head, and then this is the fault plane. I will mark this one as the head, so that we will not consider this one as part of it. Therefore, this angle is what we refer to it as the head, because it is the inclination angle that has resulted in the process of up throwing and down throwing of this tabular rock, crustal rocks. This is actually an indication of the crustal layers of rocks that have been formed, showing distinct layers of the earth crust. Therefore, we have to use some different pattern here so that we'll be able to understand this is actually the earth crust that is shown here, having distinct layers, because that is what geomorphologist advises, that all part that has been indicated must be shown with a distinct layer, and that is what we refer to it as the study of the earth crust. Therefore, when you turn it the other way around, you'll be able to find it is forming two crustal layers of rocks that have been destabilized as a result of the tensional force, therefore producing what we call the normal fault. At this plane, that is where we have the normal fault. It has just occurred where the magnitude of the down throw and the up throw are almost equal, and therefore as a result of that, it leads to this type of a fault. And we also be able to look at the reverse fault. Reverse fault occur, or reverse fault are formed when the compressional forces now will supersede the other. The reverse fault is formed or occurs when the compressional forces pushes the block of land on one side. Pushes the block of one side of the fault upward. And thus producing what we call a reverse fault, thus forming a reverse fault. The reverse fault will be produced in the process. And how is a reverse fault occur? A reverse fault appears in this manner when one layer of crustal rock is pushed above the other. Therefore, you will find that when this crustal layers is being pushed above the other, as this one slide past each other, therefore it produces what we refer to it as the reverse fault. Reverse fault is formed in this manner. You'll find that one block of land has been pushed upward above the other one, the other side, and therefore leading to the formation of what we refer to it as a reverse fault, and that is how it is, and then leading to the formation of a reverse fault which landscape the earth crust. Also, we can also look at the transcurrent fault. Transcurrent fault occurs when the fault strikes or slips past each other. When one part of the block slides past each other, and then producing what we call a shear or a shearing at the edges of the block. And that one may produce such a shape of a block can have a block of land that when you look at the shape, these two shapes represent the two blocks of land, and when these two blocks of land are brought together, they slip past each other, and therefore producing what is a shearing at the edges of each block and forming what you call a transcurrent fault, where one block will be slipping past each other on the opposite direction while the other one moves the other direction. When these two blocks of land are brought together and they slide past each other in this manner, they produce what we referred to it as the transcurrent fault. And in many of the places you will find that the force will always work around this environment. There will be two forces that will be moving. Therefore, we'll have, that is a force, and we call it the compressional forces. Compressional forces, that is the one that is working here. It is represented by the both arrows. Compressional force is the force that work against each other and then making the forces, making the two blocks slide past each other. When they don't slide past each other, when they have an equal magnitude, they will produce a different feature that we refer to it as a fold. We'll be able to look at it in the next lesson when we'll be learning about folding. Therefore, this one will produce such what we call a transcurrent fault. Let's look at a thrust fault, how is also involved in shaping the landscape or landscaping the crust. As we look at the other one is referred to as a thrust fault. A thrust fault is almost familiar with the transcurrent fault, but there is a difference about it. This one occurs when the strong compressional forces in the crust causes fault to develop in the near. It is actually occurs when there is a strong compressional force. Compressional force occurs in the crust when the strong compressional force occurs in the crust, it causes the fault causing what we call the fault to develop in a near horizontal plane. In a near horizontal plane, positioning one block of the land to thrust over each other. And this will result into the positioning of one block of land to slide or to thrust over one block of land to thrust over each other, and then forming what we call a thrust fault. Forming a thrust fault. Therefore, a thrust fault is one block of land that has been resulted when the crustal rocks has been subjected to the compressional forces that occurs within the earth crust, and therefore causing the fault in the near horizontal plane to position one block of the land to thrust over each other, and then forming what you call a thrust fault, and that one will be produced in this manner. I'll be able to illustrate it using a diagram so that we see how it thrusts over each other. It is almost similar to the to what we call transcurrent, but it causes a block of land to almost go nearly to the horizontal plane. Therefore, you'll find that this block of land is going to thrust over what was the initial part of the land, in the process resulting to what we call thrusting over. This one will wobble and therefore it will pass each other. This is a strong force that we call it strong compressional force. And then another one is produced on the other side. Therefore, when these two forces are meeting, there will be what you call a thrust fault. A thrust fault will be formed eventually and leading to the formation of this cape of land that shall be formed in the process, as you'll be able to find it. You will find on some areas of the earth crust there is a formation of such a diagram or such a representation on the scape of the land. This is what we referred to it as a thrust fault, and it has been formed. Lastly, we'll look at the anticlinal fault, and anticlinal fault is formed by a massive force of compressional force that may develop anticlinal fault. Anticlinal faults are caused when massive compressional force, especially on the anticline, there is a further compressional force that results into the crustal rocks to fault around the crests, and therefore producing what we call the anticlines as a result of the tensional forces. Therefore, when we look at the anticline, anticline is a part of the upper fold. When we look at the fold, especially this can represent a better part of the earth surface. Now, when there is compressional forces working on these crustal rocks at the equal magnitude, it may force these crustal rocks to come into a compressed to form what we call the anticline. And when the anticline is produced, there will be further anticlinal fault that will develop on what we call on the Earth's crust. The small cracks or crevices will develop, and as they develop, they will cause what we call some anticlinal fault developing around these regions, leading to what we call the anticlinal faults. And when these parts are subjected to what we call now erosion or weathering, therefore we will have some anticlines that have been developed, some furrows on the what we call the anticlinal fault will be developed when you subject this piece of the earth crust on erosion. Especially we will have some massive furrow, we call them massive furrows, will develop now resulting into a different feature that will be able to scape the land alongside the forces. Call them the compressional forces are working on both sides of the earth crust, and therefore producing what we call the anticlinal fault. Remember, when this crest produces, we call it an anticline. When it is in its original state, it is referred to as an anticline. Therefore, from the word anticline, it produces what we call anticlinal fault. These are some few faults that are developing along the crustal surface, and then away from these, you'll be able to look at the resultant features being produced at the various sides of the earth crust, and therefore leading to the formation of the different landscape. If it is to complete it, it may look like this. Therefore, these furrows may just continue to be indicated, and therefore forming what we call the anticlinal fault, forming furrows of gullies upon when they are subjected to various level of erosion. And therefore all these types of faults or categories of fault in the process of faulting may lead to the formation of various features that are going now to scape the land. What are the effects? That is what is now known as the landscaping of the crust, the effect or the resultant features. effects of faulting. We can also be able to outline it as the resultant features, because it may produce some features that are different when we view at them, and then resulting to the formation of some various features. Therefore, faulting may result into a variety of features that are going to be found on earth crust, therefore leading to the formation of different types of the scape or a variety of rocks which have been involved in the formation of these. And one of the feature is what we call the fault scape. Fault scapes are the steep-sided slopes. These one are a steep-sided slopes along the faulted region. Along the faulted region on Earth's surface. And also, it may also lead to the formation of the fault steps, or what we call the faulted steps, which are different features on Earth's surface. It may also lead to the formation of what we call the fault block. Fault block. And also form what we call the rift valleys, or what we call the graben. The other name of the rift valley is referred to as the graben. Therefore, these are some of the resultant features that may result in the process of faulting. We'll be able to look at one of each of them and how they are developed. Let's look at fault scape. I've already looked at it and indicated that fault scape are the steep-sided slopes that are found along the faulted region. We also refer to them as the escapement. This one exists especially on the walls of the Rift Valley and over the areas where there are parallel faults they have occurred. And we have various fault scapes or faulted regions, or we call them also escapements in various regions of the earth. For example, a block may be resulted, it should be an angular form. This one is the side view. Because of the faulted regions, this one is a fault, has pushed this block upward, and therefore another one may be pushed down or may be thrown as a down draw. And then this side is what we call a fault step or a fault scarp. Yes, it is referred to as a fault scarp. It is sometime in other books we call them escapement. In that process, when a side block has occurred, especially in the faulted where the parallels faults have occurred within the earth crust, one block may be pushed over and then leaving another block on a relatively flat land. Therefore, these may be referred to as the down throw. Therefore, on the side of the down throw is what we call the fault scarp is going to be formed in the process, and therefore on the opposite side, if we'll have another block, it may result to the formation of what we refer to it as a graben or the Rift Valley. That is how a fault scarp occur. And it occurs in the area where there is what we call a lot of tensional forces occurring, especially on earth crust. Therefore, when a series of parallel lines are formed, especially on the earth crust, you will find that there will be the formation of various regions of the parallel parts of the landscape. Will be having the steep-sided slopes that are very sharp, apparently to the normal one, and some of them may have some steps that you can just look at it. Another type, another resultant feature that will be formed and can easily be seen on earth crust is fault steps. We have fault steps. Fault steps occurs when a series of fairly fault lines happens within the fault of the bedding planes of the earth crust, developing in the area of the origin. And that one will produce a series, it will produce a series of steps that are going to be resulted repeatedly in various level. And as you look at that, creating what we call a series of steps that are referred to as the fault steps. For example, when you want to climb a story building, there are some various steps you can use to ascend to the next story house. Though they look like that, but they are found on earth crust. Therefore, we refer to them as a fault steps, and they are formed in an area where the parallel lines have occurred, and therefore they develop in the regions of where there is a lot of faultings that have occurred, and therefore lead to the formation of the landscape that will produce a series of steps that are following each other in a periodic way that are known as the faultscape. And I will use a diagram to demonstrate that one very shortly. These are what we call the parallel faults have already developed. Parallel faults have developed on earth crust, and remember, this is just an incised block of the earth crust that has been embedded within the crustal layers of the rocks. Therefore, sometimes the parallel faults may occur within the earth crust, and therefore causing this block of land to sink, and eventually within a given period it also caused this one also to sink. As a result of that, it produced a series of steps. This series of steps is what we refer to as the fault steps. And therefore, the fault steps, as they are formed, they will lead to the formation of the faulted steps, especially in regions where there is such fault parallel lines develops within the crustal rocks, and therefore leading to the formation of the faulted steps in a series of steps. Now you can look at them, they are just found on the earth crust, but the difference is they look like the man-made steps that one can climb from one ladder to another as he goes upward. But on earth crust, they may be formed in various valleys and producing such features. Therefore, these will produce a different landscape on the earth crust, and that is why we have been able to look at its effect. It's one of the effects of the faulting producing such feature. Another feature that we are going to look at is referred to as the fault block. The fault block is going to be formed as a resultant feature. Some books call the fault block as the host. It may also be referred to as the block mountain. That is a feature that may also develop as a result of the block. Therefore, the fault block or the hosts, this one is formed when a land is raised above the surrounding region, where they are attained when the block of the land is bound by the fault line, either on either sides, and therefore above the ground, one land will be uplifted above the other, and then leaving the other on the neutral level. That is referred to them as the down throw, and then having an up throw. This may result to the formation of a host block or a fault block. Sometimes we also refer to them as the block mountain. And there are various block mountains or fault block that are formed it is formed when actually the compressional forces push one block of land, leaving it upwards, and then this is an upthrow, leaving it was just in the normal state, and because of these forces that have worked up on these crustal rocks, it has now made some of this bit that was here, and it has been pushed upwards, leaving an outstanding block or a host that is referred to as a host block. And when you look on each side, we will have the down throw. Maybe they will remain in this manner, and then forming various types of block or the block mountain. And we have various block mountain all over in Africa, like we have the Usambara, and then we also have the Pare, are examples of the faulted block that are found. Even when we go in Ethiopia, in Ethiopian highlands, there is a given part that is referred to as the Danakil Alps that is found in Ethiopia. It is an example of a static feature that is called as the fault block. Therefore, we also call it the block mountain or the host block. Therefore, some of these are the features that may result into the formation of the faulting. The other feature is a rift valley. You will find that a rift valley may be formed in various ways away from it. We will look at a fault block, and then in the next lesson we'll be able to look at the rift valley and how it is formed, because it is more conspicuous feature that is going to shape or going to add on the landscaping of the earth crust, and then leading to various types of grabens that we'll be able to discover them in the regions of the world as they are. That is what we have covered today. In the next lesson, we'll be able to look at the formation of the rift valley or the graben as one of the last feature that will be resulted in the process of faulting. Have a good day. Thank you.